Have you ever wondered why Musk still hasn't landed humans on Mars? Is his Mars colonization plan just a commercial hype? Or has it run into real technical obstacles? As early as 2016, Musk said humans would be sent to Mars by 2024. Later, the plan was postponed to 2026. So what exactly caused the Mars migration plan to be delayed again and again? Can humanity really succeed in rebuilding an Earth 2.0 on Mars? Today, based on the real conditions on Mars, let's talk about how big the differences between Mars and Earth really are, and just how hard it is for humans to land on Mars. In the solar system, when Mars is closest to Earth, it's only about 55 million kilometers away. At its farthest, the distance reaches 400 million kilometers. That's why probes headed for Mars are always launched only when the two planets are tens of millions of kilometers apart. Right now, several probes are still exploring the Martian surface and orbiting this red planet, and their conclusion is clear. Mars today is even harsher than Earth's polar regions. Although data suggests that 3.5 billion years ago Mars may have been warm and wet, much like Earth. Today, Mars has written uninhabitable into every inch of its surface. Why do we say that? There are roughly 5 reasons. The first is the atmosphere. Mars's atmosphere is only about 1% as thick as Earth's. On Earth, when you climb just a few kilometers up a mountain, you can already feel the air thinning to the point where it's almost gone. But Mars's atmospheric pressure is only 0.6% of Earth's. About 95% of it is carbon dioxide, and oxygen makes up just 0.13%, even thinner than in Earth's deserts. Worse still, Mars long ago lost its life-saving shield, its magnetic field. 4 billion years ago, Mars cooled too quickly because of its small size. Its internal dynamo shut down, and once the magnetic field disappeared, the solar wind rushed in, like a hurricane blowing through a house with open windows, stripping the atmosphere away bit by bit into space. Even today, Mars is still losing about 100 particles of atmosphere every second. Over billions of years, no matter how thick the atmosphere was, it couldn't survive that. Have you ever wondered what Mars looked like back when it still had a magnetic field? The second issue is temperature. Temperature swings on Mars are extreme. The average surface temperature is about -63 degrees Celsius. In winter, the polar regions can drop to -125 degrees Celsius. In summer, the Martian equator can barely reach 20 degrees Celsius. But as soon as the sun sets, the temperature plunges to tens of degrees below zero. Why is it so extreme? Because Mars's atmosphere is too thin to retain heat. It's like sleeping in winter without a blanket, warm during the day under the sun, and frozen solid at night. If you plan to go to Mars, you'd better go out during the day, because at night, I'm afraid you wouldn't even be able to move your legs. The third issue is radiation. Radiation levels on Mars are extremely high. Without a magnetic field or a thick atmosphere for protection, radiation on the Martian surface is about 100 times higher than on Earth. Over the past 4 billion years, radiation has wiped the Martian surface completely clean. If astronauts stay on Mars for 1 year, the radiation dose they receive would be about 100 times that on Earth. If you want to survive on Mars, your best option might be to live inside lava tubes, where there's no cosmic radiation, and possibly even liquid water. The fourth issue is soil. Martian soil does contain extremely high concentrations of perchlorates, about 1 million times higher than on Earth. On Earth, perchlorates are used as rocket fuel. Imagine that stuff covering the ground everywhere. It's incredibly hostile to plant growth. Even worse, Mars has almost no usable nitrogen, and nitrogen is a key building block for DNA and proteins. Earth's atmosphere is about 78% nitrogen, but on Mars, you can't find even a trace. If you had to grow plants on Mars, what would you choose to plant? The fifth issue is the Martian ecosystem. Earth is habitable because of interconnected cycles. The water cycle, the carbon cycle, and the nitrogen cycle. Plants produce oxygen, animals release carbon, and bacteria recycle nutrients. But on Mars, water is frozen at the poles and underground. Carbon is locked in rocks. There is no life to maintain balance. It's like sitting inside a car with no engine, no fuel, and no wheels. No matter how nice it looks, it's not going anywhere. Beyond these 5 points, there's another crucial problem. The launch window. Earth and Mars align only once every 26 months. Miss it, and you have to wait another 2 years. If something goes wrong right before launch, say, a single component fails, then it's see you again in 2 years. Once the rocket launches, it must endure 6 to 9 months of space travel. This is not a vacation. Without Earth's magnetic field, cosmic radiation penetrates the spacecraft walls, essentially giving you daily X-ray scans. Some studies suggest the death rate for a Mars mission could be as high as 50%. Would you dare to get on that ship? Even more punishing is microgravity. The human body is designed for Earth's gravity. In space, bone density drops by 1% to 2% per month. Over 9 months, you could lose up to 20% of your bone mass. By the time you reach Mars, you might not even be able to stand properly, and then you still have to deal with Mars's brutal environment. Landing on Mars is another nightmare. Mars's atmosphere is too thin for parachutes to work, but not thin enough to ignore. Using rockets alone to slow down costs enormous amounts of fuel. Back then, NASA invented the sky crane just to land the Curiosity rover, lowering it with cables. That works for a 900-kilogram rover, but for crude equipment weighing tens of tons, it's useless. SpaceX says it will land directly with rockets, but where do you get 1,200 tons of fuel? You can't ship all of it from Earth. Even if you're incredibly lucky and manage to land successfully, survival is the real nightmare. A 6-person crew living for 2 years would consume about 2 tons of oxygen, and tens of tons of water. All of that would have to be produced on Mars. Although Perseverance's MOXIE experiment can convert carbon dioxide into oxygen, it produced only 122 grams of oxygen over 2 years. To reach 2 tons, you'd need thousands of machines running continuously for years. Then there's water. Digging up underground ice might work during the day, but at night, when temperatures drop to minus 80 degrees Celsius, working in a spacesuit becomes nearly impossible. Food is an even bigger challenge. Growing crops on Mars is like planting seeds inside a freezer. The soil must be sterilized and fertilized, and you'd need pressurized, heated, radiation-shielded greenhouses. Sunlight isn't enough either. Mars receives only about half the sunlight Earth does. And then there are dust storms. When they hit, you can't see anything at all. The Opportunity rover was literally paused by dust storms. As for resupply, don't even think about it. Everything must be shipped from Earth. If an air purifier breaks, you'd have to wait 2 years for a replacement. Whether you'd survive that long is anyone's guess. Look at all this. This isn't colonization, it's remote survival controlled from Earth. It's not much different from Antarctic research stations. And honestly, Antarctica is far more comfortable. Some people say Mars isn't livable now, so why not terraform it? Sounds great, but reality hits hard. The core of terraforming is thickening the atmosphere. To create a greenhouse effect, Mars's atmospheric pressure would need to rise from 6 millibars to 1,000 millibars. That would require 1,000 times more carbon dioxide than currently exists in Mars's atmosphere. Scientists have counted all the carbon dioxide available on Mars. Even if you melted all the polar ice caps, you'd barely reach 1.2%. Heating the soil to release CO2 gives about 4%. Digging carbonate minerals 30 meters deep gives about 5%. Altogether, that's still under 10%. Not even close to triggering a real greenhouse effect. That's why Musk once proposed detonating 10,000 nuclear bombs over Mars's polar ice caps to thicken the atmosphere. His idea was to instantly vaporize dry ice and water ice, releasing carbon dioxide into the atmosphere, to create a greenhouse effect and raise temperatures, making Mars more suitable for humans. But the fundamental problem remains. Even if you create an atmosphere, without a magnetic field, the solar wind will strip it away again. The tragedy from 4 billion years ago would repeat itself. To create a magnetic field, you'd need to restart Mars's core, requiring energy equivalent to dumping several years' worth of the sun's output into the planet's core. There isn't even a theoretical solution for that. All these problems make one thing clear. Humans are not cosmic wanderers. We are a local specialty of Earth. Our cells, organs, and physiological systems are all tailor-made for Earth's environment. Earth's magnetic field, atmosphere, and ecosystems are a perfect home forged over billions of years. Mars's story tells us just how rare habitable planets are, and how precious Earth truly is. Studying Mars isn't about migration, it's about protecting Earth better. By understanding how Mars lost its atmosphere, we learn how vital Earth's magnetic field and atmosphere are. By seeing Mars's dryness, we learn to cherish every drop of water on Earth. So before humanity can transform other planets, we might as well focus on protecting the ground beneath our feet. After all, the only planet that can support us peacefully, for now, is this one.